Like I mentioned before, citric acid cycle is a reaction of 8 reactions, is a cycle of 8 reactions and 8 enzymes. Initially, the acetyl group from acetyl coenzyme A. So, the main players in citric acid, acetyl coenzyme A, okay, and oxaloacetate and oxaloacetate. So, and water, okay, they combine and the enzyme is known as citrate synthase, okay, they combine to give citrate, okay, citrate OH, CH2 COO minus, CH2 COO minus, COO minus, and coenzyme A and H plus. Okay, so initially the first step in citric acid cycle is the combination of acetyl coenzyme A and oxaloacetate to yield citrate. The citrate then isomerizes to isocitrate. The citrate then isomerizes to isocitrate. Okay, so COO minus, CH2, CCOO minus, H, CH, OH, COO minus. Okay, so if you look at it, this was a tertiary alcohol to a secondary alcohol. So if you look at it, this is the tertiary alcohol and now it is the secondary alcohol. So this is isomerization. Now this isocitrate, okay, will go through two reactions, a series of two reactions to produce two carbon dioxide groups, two carbon dioxide molecules, excuse me, two carbon dioxide molecules. In that process, NADH is produced, okay, and also ATP is produced. It's a series of complicated reactions which I'm not going to go through. Okay, in that process, NADH and ATP are produced. It also gives rise to a molecule known as succinyl coenzyme A. Succinyl coenzyme A. This succinyl coenzyme A will go through a series of hydrolysis, oxidations, and hydration to produce oxaloacetate. To produce oxaloacetate. And if you remember, oxaloacetate is the compound that combined with acetyl coenzyme A in the first reaction. So when the succinyl coenzyme A, goes through a series of oxidations and hydrations, it produces oxaloacetate. This oxaloacetate will combine with acetyl coenzyme A, and the citric acid cycle starts all over again. So in one turn of the citric acid cycle, 3 NADH molecules are produced. 1 FADH2 is produced. ATP molecules are produced. Okay, so if we write this entire cycle in one reaction, acetyl coenzyme A reacts with 3 NAD plus molecules, and FAD molecule, guanosine diphosphate molecule, and of course water. What is generated is carbon dioxide molecules, 3 NADH molecules, 3 hydrogen ions, FADH2, GTP, and coenzyme A. Now, like we mentioned before, NADH and FADH2 are used up in producing the ATP molecule after oxidative phosphorylation. So these two are important molecules. Also, the GDP molecule is converted to GTP. That energy is used in converting ADP to ATP. So, as a result of one citric acid cycle, ATP molecules are produced, which are ultimately the energy giving molecules in the body.